The relative isotopic mass is the mass of an element in relation to carbon-12. The reason that this is the isotopic mass is because some elements have different isotopic forms. For example, chlorine can be found as chlorine-35 and chlorine-37. The isotopic mass is not the mass number which appears on the periodic table. The number seen on the periodic table is the relative atomic mass, or the AR. The relative atomic mass of an element is defined as the average mass of the naturally occurring isotopes of the element relative to the mass of an atom of carbon-12. On the periodic table, it is the same number as the mass number. In basic terms, it is the average mass of the isotopic forms of the element. When we think about this, we must remember that isotopic forms of elements have different values for their naturally occurring abundance on Earth. For example, let's look at the isotopic forms of chlorine. Some chlorine atoms have a mass of 35, and some have a mass of 37. In most cases, to take a simple average, you would just add the values together and then divide by the number of values. In this case, it would be 35 plus 37 divided by 2, and you would get an average of 36. But this is not how you calculate the relative atomic mass. We need to remember that we are talking about number of atoms. There are a certain number of chlorine atoms with a mass of 35 and a certain number of chlorine atoms with a mass of 37. However, within a sample, the levels of each isotope are not equal. So we take this into account when we are calculating the relative atomic mass, so that we are calculating a weighted average. Naturally occurring chlorine is made up of 75% chlorine-35 and 25% chlorine-37. This can be shown to you on a graph to show abundance data, where the relative isotopic mass is shown along the x-axis and the relative abundance is shown on the y-axis. So say we had a simple sample of 100 atoms of chlorine. We would have 75 atoms of chlorine-35 and 25 atoms of chlorine-37. We first find out the total mass of the sample. We do this by multiplying the mass of each atom by the number of atoms present for each isotope, and then we add them together. For chlorine-35, there are 75 atoms, and for chlorine-37, there are 25 atoms. So the mass of 100 atoms would be 75 times 35 plus 25 times 37, 3,550. The mass of one atom will be the mass of the total number of atoms divided by the number of atoms. So the mass of one atom of chlorine would be 3,550 divided by 100, 35.5. The relative atomic mass has a value closer to 35 because there are more atoms of chlorine-35 than chlorine-37. It is a weighted average. So the relative atomic mass of an element is defined as the average mass of the naturally occurring isotopes of the element relative to the mass of an atom of carbon-12. On the periodic table, it is the same number as the mass number. The number is a weighted average, and when calculating its value, the proportion of an isotope in a sample must be taken into account.